Hello everyone, today we're going to present a system of partial differential equations to model the xenomorph human interaction. So this is a pre-predator equation system, but we're going to modify it a little. I don't think I've seen this somewhere else for now, but maybe it already exists. You will have to let me know in the commentary section under the video. So first, we need to quantify to take into account the fluctuativity of the xenomorphs. We take into account the fluctuativity of the xenomorph. Their stealth is not a matter of choice, but of inherent design. And so it is a core component of their behavior and their capacity to kill. You have to take this into account. It is very important, relevant to this study of the interaction between human and xenomorph. Let D be the probability of detection. Probability that a human can, or any living being can detect a xenomorph. L, the ambient luminance, and M, the magnitude of any movement. C, the efficiency of the natural camouflage of our xenomorph. Then we can say that the probability of detection is L times M divided by C. So when D falls beneath a threshold, beneath a critical threshold, T, the presence of the xenomorph becomes statistically imperceptible to us. Here we can still see it. In here we can't see it anymore. Or it becomes really, really difficult for us. So the more luminance there is, the more we're going to see him. The more he moves, I don't know. The more we're going to see it, we're gonna call it heat or no. And the more his natural camouflage is efficient, the less we're going to have the possibility to detect him. So this formula is fair. This is not already the formula of life and death. So on the equation on life and death. Here, the difference in our case with the classic predator-prey models, like Lokta-Volterra, is the exchange. We see this as an exchange. Balance. Yet, the interaction between human and xenomorph is far more insidious. A human being is very dangerous in its unpredictability and resourceful chaos. These are transient variables that favors the xenomorph, unfortunately. Every heartbeat, every faltering decision we make can shift the balance. Our volatile nature, while it can be quite confounding, is equally marred by inherent vulnerabilities. It is equally mirrored by inherent vulnerabilities. Flaws that the evolutionary design of xenomorphs exploits with ruthless precision. Now, if you want to take into account the element of surprise, of the human, we have to remember that humans have a high capacity for surprise. It can cause momentary deviations in the expected outcome of the encounter, even though the ultimate equation always results in favor of the xenomorphs. The xenomorph is able to quantify our weaknesses in real time, even if we are unpredictable and if it represents statistical anomaly. It is able to have the advantage in the encounter. They are creatures unclouded by any kind of sentiment, any kind of morals, by doubts or remorse, as you may know. They perceive us through a spectrum of sensory inputs. If you want to formalize the interaction as a system of partial differential equations, as we call it, a calculus of life and death, that blends predator-prey dynamics with the inherent stealth the aliens possess. We can assume that we are working in a space omega. X is in omega and T is positive. We do not uxt the local human population density we also denote vxt the local xeno population density or activity density if we consider their movements as pulses in the environment. So, can begin by using a Lokta-Volterra like structure to represent the interaction system, since it is a predator-prey model, but we're going to modulate the predation term. By the stealth factor derived the stealth factor, and this factor is what we already saw 5 minutes ago, the inherent probability, the inherent fertility, more appropriate fertility is given by in each point of space at any time by dxt is equal to lxt times mxt divided by c, and I recall that L is the ambient luminance, M is the magnitude of any movement, and C the efficiency of the natural camouflage of the xenomorphs. L for luminance, M movement, and C camouflage. mxt is the magnitude of movement. The average, for example, the average human activity level. And C is a constant plotting the natural chemical efficiency. We assume that dxt is low when that is to say when d is hidden below the critical threshold T. The strike of the alien is almost certain. To capture this effect, continuously, we define the stealth function. With beta substitutive, a parameter controlling the sharpness of the transition around the threshold T. We can observe that when dxt is equals lxt times mxt by definition divided by c, when it is way more smaller, a lot smaller than t, the threshold, we then have that our stealth function is approximately equal to 1. So this is the optimal stealth. And if we are way bigger than t, then the stealth function is approximately equal to 0. This means for xenomorphs that they will be easily detected. So now let's present the PDE system, partial differential equation system. Using these ingredients, we can propose the following system. Partial derivative of u, that is to say the local human population density variation over time, is equal to du implication of u plus ru times 1 minus u over k minus alpha times stealth function times uv. Sorry. Then the variation over time of the population density for our xenomorphs is dv Laplacian of v plus gamma alpha times sxt uv minus delta v. So this is the system for now. du and dv are the diffusion coefficients. modeling the spatial movement of humans and xenomorphs, respectively. R. R is the intrinsic human growth rate with carrying capacity K. Alpha is the baseline predation or elimination rate. Gamma is the conversion efficiency. That is to say, how effectively consumed human life essence converts into xenomorph propagation. This would be the part referring to the facehuggers. I don't really know for now. Delta, because I was thinking maybe the xenomorphs were kind of eating the humans when they captured them. But we could also see this as a way to convert human lives into facehuggers food. Delta is the natural mortality or decay rate of the xenomorph in the absence of prey. But since the xenomorphs are very resilient over time and resourceful, we will have, because they can survive for long periods of time without even, we don't really know at all if they are feeding themselves, so maybe they do, but they don't really need to, I think. So we will definitely have to adapt this term or to use it for something else. The interaction term alpha S60 because alpha S60. So the baseline predation rate multiplied by the stealth function. The more stealth we have, the more predation we're going to have. So this can be seen as the interaction term. We also have UV, Yes, this term encapsulates, it is a very good way to encapsulate the idea, that the strike success in the of the alien strike success depends on its ability to remain undetected when the camouflage is effective. Because even though the aliens are very strong, most of the time they prefer to attack using the element of surprise. They prefer to make sure the prey will fall, minimizing any kind of reaction from the prey. They don't want to take any chances, and that's quite smart. But anyway, if it don't go as planned, they can still use their brute force to make a way and to kill their targets effectively. When the camouflage is effective, that means S60 is near 1. The predation is maximized. And of course, the more population, the more V there is of xenomorphs, the more the interaction will encapsulate, the interaction will encapsulate more the alien strike success. And the more humans there is, the less xenomorphs there are. The more humans there are, the less xenomorphs there are, the less likely the outcome will be successful for the xenomorphs. And alpha is kind of fixed. It is variable, but for now we're going to consider it is fixed. Conversely, if the environment if the environment degrades the stealth factor of the xenomorph, of the aliens through a higher luminance or heretic human motion, or if the xenomorph moves a lot. I think I will have to think about this deeper. If the environment degrades the stealth factor, then SXT will converge to 0 and the efficacy wanes. Let's talk about the initial and boundary conditions now that we came up with. To complete the model, we can specify initial conditions. Ux0 equals u0x, vx0 equals v0x for x in omega. For instance, homogeneous human boundary conditions, no flux across the boundary. We should say the normal derivative of u xt equals 0, or we can also look at the normal derivative of v xt equals 0 for all x in on the boundary, t positive. Now brief interpretation. No flux across the boundary means that, for instance, where the execution of the interaction takes place in a spatial station or in a colony, where we don't have anyone living in the colony. The humans cannot leave the colony. They are kind of trapped, surrounded by. They don't really want to go outside because the environment may be hostile. You cannot breathe. Not a good atmosphere for human health. And on a space station, you cannot go outside or else you die. So no flux across the boundary would mean something like this: an isolated environment. So brief interpretation. Humans, the population grows logistically but suffers losses through encounters with the xenomorphs. So in terms few, the population of humans grows logistically but suffers losses through encounters with xenomorphs. The xenomorphs now, the population or presence increases proportionally to successful strikes. Each is determined by the product S X T U V. And this system, while being a simplification, encapsulates the inherent calculus of our interaction, our success. Of the interaction, sorry. This success and the fate of the humans is not merely numbers. It's not merely a matter of numbers, but is critically modulated by environmental factors and the precision of the evolutionary algorithm of the xenomorphs.